Okay, another example, a tangent again. So I'm going to mark that tangent in yellow. And we've got lots of chords, so I'm not going to mark those up in blue, but I'm going to remind myself that that's a radius. Okay, let's just check the details. Points on a circumference, and they've given us that this angle here between the chord and the tangent is 58 degrees. Let's mark that as a blue chord that's significant. Calculate the size of angle OAB. OAB, well, let's put that line, that other line in there, which of course is another radius. And let's mark the angle they actually want us to find, which is this one up here. Okay, where do we go with this? Well, we're given the fact that this is 58 degrees down here, and it's the angle between a chord, the chord CA, and the tangent. Well, number 8 says that the angle between the chord is the same as the angle to the circumference. So this is this angle up here, all of it. So this angle here is 58 degrees. But that's not the angle they want us to find. They need us to find the smaller angle here. Now notice what they've also told us is that CB is equal to AB. So this forms an isosceles triangle with 58 degrees at the top. And the angles in that triangle will, of course, add up to 180 degrees. So we can say that 58 plus x plus x, the angles at the bottom here being equal because it's an isosceles triangle, must equal 180 degrees. So therefore, 2x is equal to 180 minus 58, and that equals 122. Therefore, x is equal to 122 divided by 2, which is 61 degrees. So we've got this angle here as 61 degrees, and this angle here as 61 degrees. Diagram's getting a bit messy, but I hope you can still see what's going on. So our focus now should shift to the triangle OAB, of which we need to know this top angle. Notice also, and the benefit of marking the radii when we started the question, is that it's another isosceles triangle, which means these two angles down at the bottom here will be the same. So if we can find this angle, we're home and dry. Effectively, AB is another chord on which two lines are subtended to the center and two lines are subtended to the circumference. And Theorem 2 states that the angles to the center of a chord are double to those of the circumference. Okay, well, it means that the angle AOB is double 61, which is 122 degrees. So if AOB, this angle here, is 122 degrees, it means the bottom two share the rest of the 180 between them. So we can say that our angle that we need, which is the angle OAB, must equal 180 minus 122 divided by 2. And that is equal to 29 degrees. And there you have it. Once again, I urge you to write your workings out on the paper and give reasons. In other words, state the theorems that you're using to produce those answers.